First we need to multiply this out, and since it's an a minus b times an a plus b, the result is a squared minus b squared, or 5x squared minus 2y squared equals 200. So in other words, this is 25x squared minus 4y squared equals 200. To be in standard form, we need it to equal 1. So divide by 200 on both sides. And that's the same as dividing each term by 200. Now 25 goes into 208 times, so this is actually x squared divided by 8. And 4 goes into 250 times, so this is y squared over 50 equals 1. Now we can write this in standard form as 1 divided by the square root of 8 squared, x squared divided by the square root of 8 squared minus y squared divided by the square root of 50 squared. Now, although we could simplify each of those radicals, there's really not much point in it. What we need to do is numerically evaluate them so as to see what the intercepts are. But first of all, let's see which way this goes. If y is 0, there are solutions for x. But if x is 0, there are no solutions for y. So this is one of those hyperbolas that goes sideways, because there are x solutions for x when y is 0, but not for y when x is 0. So that's the way these go. But we need to calculate the square root of 8 and the square root of 50. We need to know approximate numerical values for them. So 8, square root of 8 is about 2.8. And the square root of 50 is about 7. 7.07. So in any case, we can now draw the box with the diagonals that'll help us graph our hyperbola. So here we go. So first we draw our x and y coordinates, axes here. And notice that the x box goes out to 2.8 and the y one goes up to 7.07. So let's make this 1, 2, 3. So 2.8 is about here. And the other way, negative 1, negative 2, negative 3. And so negative 2.8 is about here, a little bit less than 3. Now we have to go up 7 and down 7 about. So 1, 2, 3, 4, 5, 6, 7. We're about there, a little over 7. And 1, 2, 3, 4, 5, 6, negative 7. So that's the extent of the blue box that we need to draw. So actually, let's do it. So the blue box looks something like this. And there's the blue box whose diagonals we need. To help us graph the hyperbola. So our hyperbola comes like this, asymptotically approaching that dashed line, then on both sides, cutting through the x-axis at that point, which is the square root of 8. And on the other side, the same thing happens. So we have this asymptotic curve approaching this line, coming in, cutting through the x-axis at negative 3, and then approaching its asymptote on the other side. So there we have it, the graph of this hyperbola.